So hello, I'm gonna give the explanation for the coding one. In this code, we will explore the usage of stack in data structure C++. What is stack? A stack is a last in first out, which is default data structure, which means that the last element inserted in the first one to be removed. We will also demonstrate how to find the last element in the stack after popping all its elements. So I'm going to explain about the code. So the first thing in the code, we should include the necessary headers. So the code begins by including the IO stream and stack headers. The IO stream header is essential for input and output operation, while the stack header allows us to use the stack data structure in C++. So next thing is creating a stack. So next we declare a stack named myStack of an integer type using the stack in template. This stack will store integers. So third thing is we push elements into the stack. So we push 4 integer elements, which is 2, 1, 2, 0 into the stack. Using the push method, the elements are added in order they are pushed, which is resulting in the stack 0, 2, 1, 2. So the fourth thing is we print stack elements before popping. So to demonstrate the elements currently in the stack, we enter a loop that prints each element while not empty. It uses the top method to access the top element and pop to remove it. The loop prints stack elements before popping 0, 2, 1, 2. Lastly, print the result. After fixing the code, the program currently finds and prints the last element of the stack. If the stack was initially empty, it displays an appropriate message indicating that there's no last element. So, in conclusion, in this demonstration, we learned about the stack data structure and the first in first out behavior. So this is the coding for the first question. So that's all from me. Thank you. So this is a C++ code which defines a basic queue data structure using a structured name queue. So the queue is implemented as an array of characters with a fixed size of 3. So the queue structure has the following member function. It has 5 functions in this coding, which is the constructor, is full, is empty, enqueue, and dequeue. So the first thing is the main function, the function of the constructor. So the constructor, the function is it initialize the front and rear indices of the queue to the 0 when a new queue object is created. So the next thing is full. This function checks whether the queue is full or not. It returns true if the rear index is equal to the maximum queue size. So it also indicates whether the queue is full. So the third thing is empty. This function checks whether the queue is empty or not. It returns true if the front index is equal to the rear index, indicating the queue is empty as well. So the fourth is enqueue. This function is used to add the elements to the queue. It takes the character as an item as an input. So if the queue is not full, check with is full. It inserts the item at the rear index of the elements array, increments the rear index to make the space for the next element. If the operation is successful, it returns true, otherwise it returns false. So the fifth function is the queue. So this function is used to remove elements from the front of the queue. If the queue is not empty, check with this is empty. It prints the element at the front index and increments the front index and effectively remove the front elements from the queue. If the operation is successful, it returns true, otherwise it returns false. So let me explain the coding part in the main function. So In the main function, a queue object named as a queue object named as my queue is created. So three characters are also is there. So the first thing is letter 1, letter 2 and letter 3 are defined with the values of P, U, O respectively. So the next is your characters letter 1, 2, letter 3 are enqueued with the my queue using the enqueue function. So then a while loop is used to dequeue and print elements from the queue using the dequeue function. The loop will run until the queue becomes empty. So overall, this code demonstrates the basic functionality of the queue data structure, where elements can be enqueued and dequeued in the first in, first out, which is FIFO manner. That's all from me. Thank you.
Good day in Chaik Malisham. My name is Harish Ragavendran Analalaki Murugesan and my matrix number is 01DD322F1131. First of all, I would like to thank my friend Praavieen for explaining question 1 and 2. So let me explain question 3. So these are the code for we built for question 3. Let me explain it. First, the necessary header file IOStream is included, and the using namespace std directive is used to avoid writing std double dot double dot before standard library functions and objects. So next, a struct node is defined to represent a node in the binary search tree BST. Each node has an integer key value int key and two pointers node left and node right. It to its left and right child nodes respectively. So the function new node in item is defined to create a new node with a given integer item. It allocates memory for the new node using the new operators, sets its key value to the given item, and initialize the left and right child pointers to null. The function the function then returns the pointer to the newly created mode. So then insert node times node int key function is defined to insert a new node with the given key value into the BST rooted at node, and it is recursively finds the appropriate position for the new key in the tree and inserts it accordingly. If the node is null, it means the tree is empty. So it creates a new node with the given key using new node open bracket and close bracket and returns it in a new root of the tree. So finally, the find min node times node function is defined to find the minimum key node in the subtree rooted at a node, and it iterates down to the left children of the nodes until it reaches the leftmost node, which is the minimum value. So that's all for my explanation for question 3, and the rest of part will continue by my friend Soman. Thank you.
Good day to everyone. My name is Soman Kannalan. Matrix number is 01DDT22F1031. Before I begin with the next explanation, I would like to thank Harish. So, to begin my part, I'll continue with the next point, which is the delete node function is defined to delete the node with key value k from the BST rooted at root. It uses recursion to find the node to be deleted, and depending on the node's position and number of children, it handles the deletion accordingly. So, if the key k is less than the root's key, it recursively calls delete node on the left subtree. If the key k is greater than the roots key, it recursively calls delete node on the right subtree. If the key k is equal to the roots key, it handles the deletion, such as if the node has no left child, it returns its right child as the new root after deleting the current node. Next, if the node has no right child, it returns its left child as the new root after deleting the current node. If the node has both left and right children, it finds the minimum key node in the right subtree, replaces the current node's key with that minimum value, and then recursively calls delete node on the right subtree to delete the original node with the minimum key. Next is three tree transversal functions are defined as in order, pre-order, and also post-order. These functions recursively traverse and the tree and print the node keys in the specific order. So first is in order. In order follows the order left subtree and then current node followed by right subtree. Next is pre-order. Pre-order, the order is like current node, next is left subtree, and the following will be right subtree. Last one is post order. Post order's order is left subtree, right subtree, and finally current node. So to talk about the main function a pointer root to the BST is declared and initialized to null. Then a series of insertions are performed to build the initial BST. Nodes with keys 50, 30, 20, 40, 70, and 60 are inserted into the tree using the insert function. The program then prints the in-order, pre-order, and post-order traversals to the BST. Three nodes are deleted from the tree using delete node function, one for each case, deleting a leaf node 20, deleting a node with a single child 70, and deleting a node with both children 50. After each deletion, the modified tree is printed using in-order traversal. Finally, the program returns to 0 to indicate successful completion. So that's all from me. Thank you.
Assalamualaikum and selamat sejahtera. My name is Izzuddin bin Abdul Halim. My matrix number is 01 DDT 22 F1086. Okay, for this question, first, separate the queue between two. Hence, the mid will be index 4 with the element 34. First index will be 0 with element 5 and last index will be 8 with element 58. So now we can notice that 50 is more than 34. Hence 50 will be in between the index 4 and 8. If he calculated again between index 4 and 8, the mid will be index 6. First will be index 5 and last will be index 8. Now that in the remaining set of Q, we can identify that 50 is in the index 7. Hence, it is proven that 50 is successfully found.